this is too complex, I don't want this, and walked away. Now, I could go into the history, but basically he didn't want a scale-up environment. He wanted little boxes because he could see, he was comfortable with that. We put it in because the CIO could see the business value what this was doing. Now I happened to be back on that site some 6 months later. Same operations manager came to me, different personality. His answer was, this stuff is great, it just works. If I don't touch it, it does everything you said it would do. And that's the problem we have in this environment is we can do all of this, but people don't trust it. They think this is going to make my life hell. And this is what Wayne thought. This is going to make my life really difficult. 6 months later he's going, this makes my life great. I don't touch it, it works. It's integrated by design. And that was quite a revelation to me because we actually, as this particular operations manager had planned to never buy more than a 4-socket box. We put the first SuperDome in there, he really dragged his heels, he didn't want it. And I said, he even told me he didn't want it. 6 months later, not only did he want it, he was leading the charge to get these into production. It was the first time we did disaster recovery. That site now has 5 SuperDomes running all their enterprise environment, very successful. Complete change around over a couple of years. And it took changing the people first. Because this, he thought, was hard. When you see how the tools work, how our resources have dropped back to 2 CPU here, they dynamically scaled up, they scaled back based on the load. We didn't have to touch it. You can put in a lot of configuration, you can make things fairly complex, or you can keep it simple. Just look at the load and just rebalance based on the utilization. Lots of flexibility. And that's sort of been my experience. Is a lot of the problem we have here is actually getting people to understand. That's one of the reasons for putting this demonstration together. Okay, how are we going for time? What time do I have to have you guys back for lunch? I don't want to...
We can go.
Basically, we all hope it never happens, but Murphy is a person who says if something can go wrong, it will go wrong. So we need to be aware of that. So I'm going to start a scenario here, and I'll just start it and I'll talk to it before we even come to here, because it happens fairly quickly, and I'll come back to that when things are happening. So what we're going to do is take a server down. In fact, I'll jump through first. Dum, 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 dum. Come to here. We've got a server scale cluster here. We're going to crash that server. And I'll leave it at that, and we'll see what happens over here. Because it actually happens fairly quickly, and I find if I'm talking too much over here, it's all gone. So we've got across both lines of businesses now, we're actually driving transactions through both. So one's the green line, one's the blue line. Putting it through both, and then what we'll do is shut down the second server. And it becomes fairly obvious on here when it happens, because response time goes to infinity, throughput goes to 0 in one line. Now notice we're going to bring it up onto this database server here. Again, notice we've got 2 CPU. Where are we? Yeah. This is what I hate about live. It's like, I'm going to have it soon. So there we go. Okay. So we've got the message down here where it's actually holding the server, the hold's finished, and there goes my response time, right? So it's stopped responding. Throughput's come back down to 0. Ah, okay, hang on, but didn't I say we had 2 CPU over here? We've got 4. Where did that come from? Okay, I'll explain that in a minute. There's a number of technologies we have. ICAP is really, really useful for all sorts of reasons. So if I'm using, in say VPA, I can actually move a physical CPU from one partition to another. Because they're all software separated, so what I do is tell this operating system stop using a CPU, You actually give it the firmware, it wipes the cache memory, and then can present that CPU to another partition. So there's no data contamination, but now it's got that CPU moved. If I've got electrically isolated partitions like in-car, I can't do that. So from here to here, I can't do it. What I can do is transfer the license. So I can turn one off in this partition, I can turn one on in that partition. So effectively I've moved the resource, but I haven't moved the physical resource, I've moved the license for it. Let me come back to this one. That's where we went down. There's the 1 minute. There's my starting recovery, and here we are back processing. There's the 2 minutes. So within 60 seconds, we took an active database that failed, and what we did here, I come back to this environment, we took this server down. Service guard is running in this environment, so we're just monitoring both all the time and says, okay, hey, that's not responding, I need that database somewhere else. Moved it there. Started getting it straight up. At the same time, because we're integrated by design, the GICAP technology, or the instant capacity technology, says I can move the licenses from here, the failed machine, to here, and enable my ICAP. So I don't have to pay temporary instant license here. I'm actually just moving my license from machine to machine. Now, we allow you to move that license anywhere. So you could actually have production in Singapore, disaster recovery in Cupertino, and if Singapore fails, move the license to Cupertino and power them up with no additional cost.
So to move the license, can you move it to a larger partition than you were on before? If you're actually need more capacity with the same license.
What you've got is a license per CPU. So if you move 5 licenses, you can turn on 5 CPUs. If that, you can actually shut down 2 or 3 machines over there, move all of those licenses to another one to make it 16 CPUs. It doesn't matter. One license is 1 CPU. How many you turn on in the other partition doesn't matter.
So I've got kind of I guess I've got the CFO question. You know, obviously you have these unused, unpaid for processor cores or whatever it is. Obviously the hardware isn't free. What's the financial kind of carrying cost of maintaining those in reserve?
Okay.
And what kind of preparation do you need to do when you're implementing one of these machines where you decide, well, how many of these are we going to keep in reserve, and how much does it cost to keep them in reserve versus use them when they're activated?
Right, and that's probably too long a discussion for today, but it is the discussion that you have to have, because what is the return on investment? So it all comes down to things like, how often am I going to turn these on, and for how long? So GICAP, different GICAP, what's the number, 30% for the CPU? I think it's 30%.
Yeah.
So you pay 30% charge, so it's not free, but it's there. I can now move my license across machines, across everything in my domain. So that gives me a lot of flexibility. So if I'm working around the world, or I could actually say it allows me to reduce disaster recovery type environments significantly, because I can reduce the total cost of the hardware, but still have the capability to be full production. So in some of the others, and things are, say, temporary instant capacities, that one more comes down to how often am I going to turn them on. If I'm going to turn them on for 5 hours every day, it's more economic to buy. If I'm going to turn them on for specific peaks, then it can actually